energy levels, sublevels, and orbitals. In the quantum mechanical model of the atom, we no longer talk about the word orbit or orbiting around the nucleus. We talk about orbitals, where orbitals are volumes or regions around the nucleus where there is a high probability of finding an electron. We can think about the orbitals as clouds or blurry energy regions around the nucleus. Different orbitals or different probability regions have different names. We can start with the s orbitals. The s orbitals have a spherical shape and they can hold at most 2 electrons, one spinning clockwise, the other spinning counterclockwise. On the other hand, the p orbitals can be shown along the y-axis, along the x-axis, and also along the z-axis. We can show them as lobes along the y-axis, 2 lobes, where there's a high probability of finding 2 electrons. Along the x-axis, again 2 lobes, where we have a high probability to find 2 electrons. Along the z-axis, 2 more electrons can be filled into the p orbitals. When you add up the p orbitals, they do exert a spherical region in space also. So we can show them as lines. We can have at most 3 p orbitals holding 1, 2, 3, 4, 5, 6 electrons at most. We can name these p orbitals as they lie along these axes, px, py, and pz orbitals. Next, we have the d orbitals. The d orbitals have various shapes, but they are 1, 2, 3, 4, 5 d orbitals, holding a total of at most 10 electrons, 2 electrons in each orbital. We can name these orbitals related to their shapes p minus 2, p minus 1, p 0, p plus 1, and p plus 2 orbitals. Next, we have the f orbitals, and there are 7 f orbitals altogether, holding a total of 14 electrons at most. The shapes and sizes of these orbitals are much more complicated than either the p or the d, but when you add all the f orbitals together with electrons, filled completely with electrons, they do somewhat have a spherical shape also. Now, how do these orbitals fit into the energy levels around the nucleus of the atom? We can resemble the atom to a building which has a very small room at the very bottom. The floors, as you go up, the distance between the floors getting less, and less. And in each floor, a greater number of rooms are added. So in the first floor, we have only 1 room. In the second floor, we have 2 rooms. In the third floor, we have 1, 2, 3 rooms. In the fourth floor, we have 1, 2, 3, and 4 rooms, and so on as we go up. We can show as we go up that the energy of the levels and the electrons increase as you go up the building. Let's resemble this building to the orbitals, and let's put these orbitals into the energy levels of an atom. This is the nucleus of the atom. Imagine that this is the nucleus, and we start with in n equal to 1, the first energy level in the atom. The first energy level has only 1 sublevel, and we call this sublevel the S sublevel. Or we can call it, because it's in the first energy level, 1s sublevel. The 1s sublevel has only 1 orbital inside it, and this is the s orbital. And this s orbital can hold a maximum of 2 electrons. Now let's pass on to the second energy level. The energy difference between the first and the second energy level is much greater than any energy difference as you go up. So this is the second energy level. Because of the population of electrons and the repulsion between the electrons in this population, the second energy level is divided into two sublevels. We call these sublevels, according to their size and shape, the S sublevel. Actually, we can call it 2S because it's in the second energy level, and the 2P sublevels. Again, the P sublevels can be named as, remember we call them S, X, P, and Z, PX or 2PX, 2PY, and 2PZ. We can put the electrons into these orbitals. In the second energy level, we have two sublevels, the 2S and the 2P sublevels. 2S sublevel has only one orbital, the S orbital, 2S orbital, and the 2S orbital can have a maximum of 2 electrons. If the atom has more electrons, these electrons can be filled into the 2P sublevel and the 3 orbitals in the 2P sublevel. These 3 orbitals can be filled as one at a time and then pairing up with 6 electrons. Now, coming to the third energy level, we have N equal to 3. And the difference of energy between the energy levels is getting less as you move up. So, in the third energy level, because again of the huge population of electrons, we have a splitting up into 1, 2, and 3 sublevels. Let me erase this building, which we resemble to the atom, because we're going to fill in as we go up and we need more space. The third energy level is made of 3S, 3P, and 3D sublevels. Each of these sublevels containing 2 electrons in 3S. In the 3px, 3py, and 3pz orbitals, 2 electrons in each, holding a maximum of 6 electrons in 3p. And the 3d sublevel, there are 1, 2, 3, 4, 5 orbitals, 3d orbitals, holding a maximum of 10 electrons. Let's fill in the 10 electrons in these orbitals. Now we have come to the fourth energy level. The energy difference between the fourth energy level, N equals to 4, and the third energy level is getting even smaller. The fourth energy level is split up into 1, the 4s, 2, the 4p's, 3, the 4d's, and the 4f sublevels. We can call them 4s, 4p, 4d, 4f. At this point, it's very important to notice that there is an overlapping between the 4s and the 3d sublevels. The energy of the 4s sublevel has become less than the energy of the 3d sublevel because of the overlapping. So as we go up to the 5th and the 6th and the 7th energy levels, this kind of overlapping between the S, D, and the F is getting more or more. Therefore, we need another way of expressing or putting these energy levels, sublevels, and orbitals in an order. We call this the off-bow principle. The off-bow principle says that when filling in atomic orbitals, We start filling in from the lowest energy level orbital and fill in according to Pauli exclusion principle. Pauli exclusion principle says that in any atomic orbital, we can put in a maximum of 2 electrons with opposite spins. Opposite spins means one turns clockwise while the other turns counterclockwise to minimize the repulsion between the 2 electrons. Remember that in the previous slide we were drawing energy levels, sublevels, and orbitals, and when we came into the 4th energy level, an overlapping started between the 4s and the 3d orbitals. And this overlapping increases as we go up to higher and higher energy levels. How can we solve this problem of overlapping without drawing these orbitals each time and trying to figure out where the overlapping is taking place? There is a rule which we can use for this. We can write down the energy level and the sublevel in each energy level, starting with 1s. In the first energy level, there is only one s sublevel and s orbital. Then go down, but move one across and start filling in the second energy level sublevels as 2s and 2p. Move one down, move one across, 3s, 3p, 3d. Move one down, move one across, 4s, 4p, 4d, and 4f. One down, one across, 5s, 5p, 5d, 5f. 6s, 6p, 6d, and we can even write 7s as we move across. Now we take our pen and start from the bottom of 1s, the first energy level, to the top of the 2s, the first orbital in the second energy level. Make an arrow, and this shows the direction of energy. From 2s, bottom, to the top of 2p, from the bottom of 3s to the top of 3p, from the bottom of 4s to 3d, from 5s to 4d, and from 6s to 4f. Now we have the order of filling in the energy levels if we follow the arrow. The arrow shows us that in 1s, which is the lowest possible energy orbital, is followed by 2s, 2p, 3s, remember that I'm following the arrow, 3p, 4s, 3d, 4p, 5s, 4d, and so on. We can, in this order, say that the energy is increasing as we move from left to right. Increase in energy.